All right, so today we'll start off with something I forgot to talk about last week. Has anybody come across any examples of math in real life in the last week or two? Something that happened that, you used math. You do this every day, you just have to kind of be aware of it. I'll start off with one example. And it's a really silly example, but I use a lot of Kleenex. So I was wondering, on average, how much Kleenex does each American use? And I would say maybe yearly. If I were smart, which I guess I am, so maybe I'll look into this, I would invest in Kleenex because I probably single-handedly keep that company alive. All right. All right. So anybody else have any ideas? Nicholas, I can think of one for your situation. How many miles did you travel from Denver to get to New York City? You might not know,
Um,
but
we were probably traveling like 250 miles per hour on the plane.
right.
And then it took 3 hours. So, um,
Okay. So there you go. There's a math problem and it applies to real life. So if you are going 250 miles per hour and it took 3 hours, basically that's a pretty simple little math problem. That's 250 times 3. Anybody want to work that out?
750
There you
miles.
go. So approximately 750 miles. I'm not sure if that's completely accurate, but it's a good guess. Yeah. All right. So just be aware of these things as you come across them in real life. And Jacob, yeah, thanks for joining us. He just typed into the chat. Right now, we're just talking about some examples of math in real life that we've come across in the last few weeks. Okay, but we'll move on. And you guys have been doing something a little different. You kind of switched gears and you've been moving into different types of graphs. You've been looking at bar graphs and line graphs and skim and leaf plots. Basically, just a lot of different ways to take data and present that data in a picture format. So we actually have enough time today that we will watch a little brain pop video on graphs and then we'll do some practice. So here we go. Sit back and enjoy.
Cruising around the Caribbean in search of adventure. This sure is the life, isn't it, Moby? Whoa, what's this? Welcome, travelers. We have learned that you are searching for the monster of youth. Follow these clues and eternal childhood will be yours. A monster of youth? I've never heard of it. But, well, okay, let's do it. For your first task, you must find your way to the Caribbean nation with the most ducats. Ducats? Oh, money. Well, sounds like a job for my trusty world fact book. You can find anything in here. Let's see. Caribbean countries with the coolest flags. Caribbean countries with the most spectacular shipwrecks. Here it is. Caribbean countries with the highest gross domestic product. Oh, that's a measure of how much money a country has. But, this list of numbers is all garbled and confusing. Maybe we could use a graph to help us visualize which one has the most, ducats. Well, I'm thinking we can use a bar graph. First, we list all the independent countries of the Caribbean along the bottom, or x-axis, and on the left-hand y-axis we mark off levels of, ducatage. We can use the graph to compare values of money per person for each country.
Let me just pause it right there for a second and just point out that this is something that you'll need to know just for the rest of your life, basically, that this horizontal axis down here is called the x-axis. And then the vertical axis is the y-axis.
Okay. Looks like we're headed to...
I can't hear anything. Something's wrong with my
Uh-oh.
I wonder what we
computer
can now.
connection.
Let's find this monster of youth. Ah. Well done. For your next clue, you must find the Bahamian island with the largest area compared with the area of all the Bahamas combined. Godspeed. Okay, who's sending us these things, and how can they see us? Well, let's go back to my fact book. I have a listing here of the biggest islands of the Bahamas, sorted by area. I think we should use another graph to help us see it more clearly. Since we're graphing pieces of a whole, let's use a circle graph, or pie graph. Right, the island of Abacao has 1,680 square kilometers, Acklins and the Crooked Islands have 520 square kilometers, Andros has 5,960, and so on. Andros Island has the largest slice, so I guess it's the island with the largest area. Off to Andros, my good man. Robot. Huh, I don't see any birds. Wonder if we made a wrong turn. Ah!
Turn left onto US 1 Tron.
Hey, just an octopus. Nothing to see here. You have proved yourselves worthy seafarers. For your final task, you must find the nest of the naval Bahamian charnies. Once there, you will encounter the legendary monster of youth, Curio. What the heck is a chick charney, and where am I going to find one?
In half a mile, turn right for OMG 139 Hotel Broken.
Yeah, me too. I'm starting to wonder whether these chick charnies exist at all. I mean, I'm all for finding the monster of youth, but what's the point if it's going to take us forever? Let me double check my fact book to see if they even exist. Huh. Well, according to this line graph, the number of chick charney sightings has increased steadily over the last 300 years. Yeah, see, the number of sightings is plotted against the scale of years from earliest to latest. You know, Moby, they could be extinct. What's that? What could it be? So funny looking.
Turn right for OMG
Hello.
139 Hotel Broken.
I am the monster of youth. I'm afraid you're changing. My powers of granting eternal youth are all used up. I can only sit around these fair forests sending parchments to youngsters like yourself and offering words of wisdom instead.
Okay, so what wisdom do you have for us?
Sure. Plastics, my dear boy. Plastics.
Okay.
Gee, thanks.
All right. Okay, so let's go ahead and take the quiz and see how we do. And then we'll actually practice making some different graphs and analyzing graphs. But I'm sure we can
I
handle
didn't hear part of it.
What was that, Nicholas? I'm sorry.
I didn't hear part of the video.
Oh, I know. Well, I bet it's because you're on a mobile device and not a computer, so it's going to be kind of a lot of feedback and a little bit laggy for you. But I bet you're smart enough to be able to, figure it out. These questions are probably pretty easy, and I'll help you. And Jacob, all he said at the end was something about invest in plastics, and that was his advice, which was kind of just silly. But okay, here we go. Question 1. Graphs can help you visualize data. What does this mean? Choose the best answer. So go ahead and let's type into the chat either A, B, C, or D. So is it A, graphs can help you better understand data by presenting it in an easy to read format? B, graphs are always pretty to look at? C, making graphs requires basic knowledge in optics and data entry? Or D, graphs present information without using numbers, letters, or words, only pictures. Graphs can help you visualize data. Okay. Yes, this is good. I'm getting a lot of people saying it's either A or D. Those are both looking pretty good to visualize data. So graphs can help you help you understand data by presenting it in an easy to read format, or graphs present information without using numbers, letters, or words, only pictures. That's not necessarily true. Sometimes they do use numbers. So let's see. Oh, I guess it won't tell us till the end. Okay. Number 2, in a bar graph, how does the x-axis differ from the y-axis? Okay, is it A, the x-axis represents positive values and the y-axis is negative values? I don't think it said anything about that. B, numbers are placed along the x-axis while words are placed on the y-axis. C, the x-axis is very long and the y-axis is very short. Or D, the x-axis is a horizontal line and y is a vertical line. Yes, this one's pretty easy. Good. Okay, oh, sorry. Went a little too fast there. What graph should you use if you're comparing parts of a whole? A bar graph, a line graph, a circle graph, or a box and whisker graph? Okay, let's wait for a couple more people. Go ahead, Autumn.
Is it C?
Yes, it is C. Very good. And awesome. I like how you guys are both, raising your hands and typing into the chat. That makes it really easy for me to see everybody. Okay, number 4. The following graph breaks down by percentages what kids in Tim's class are going to eat for lunch today. What can you learn from this graph? Well, A, that nobody likes bologna sandwiches. B, that more kids had peanut butter for lunch than any other option. C, that tuna fish is the most popular lunch option. Or D, that more kids ate ham and cheese than bologna. Okay, very good. Go ahead, Sierra. Which one is it?
Is it B?
It is B. Very good. What is a graph with lines connected to data points called? So a picture of something like this. Is it A, a line graph, B, a data point graph, trend graph, or a circle graph? Go ahead, Nicholas.
It is a line graph.
This is a picture of a line graph, and you can see the line. That kind of makes sense. It's a line, so it's a line graph. Number 6. Which kind of graph would you use to show how the price of bread has changed over time? Ooh, I see kind of 2 good options. One is slightly better than the other. What do you think, Sierra?
I think it's A.
So a bar graph with maybe the price along the side and then the year across the bottom, or a line graph where you connect the dots. Ooh, it's either A or B. Type into the chat which one you think is a better choice, A or B. Okay, I got 1 vote. Okay, I got another vote, and more people, it looks like. Oh, wow, we might be split. Okay, so, wow. Looks like slightly more people said line graph. Okay, number 7. Tim has played baseball for 5 years. Each year, his batting average has increased by 0.10 of a point. If you plotted Tim's batting average on a line graph, what would it look like? Okay. So it increased. So it starts, kind of towards the bottom of a graph, and then it's going to start kind of going up. It goes up very short or small, but which one would show a little bit of growth? Good. I'm getting everybody saying D. Awesome. There are 15 kids in Tim's class. If you wanted to use a graph to plot how tall each of them is, which type of graph would you use? A circle graph, a bar graph, a line graph, or a box and whisker graph? I see two good answers. One is better than the other. I think a bar graph would probably be better, but we'll put it and we'll see what they say at the end. Another name for a circle graph? Pizza, cake, pie, or box? Yeah, that one's pretty easy, actually. It is just a pie graph or chart. Last question. A graph shows the number of calories in 5 separate types of cookies. How can you tell which cookie has the highest number of calories? Okay, so it's a bar graph. So the bar that goes farthest up the y-axis, which is that vertical axis, the bar that is like the widest or fattest, its bar is twice as large. Oh my goodness, or the bar is the shortest. Good, I'm getting everybody who is saying A. Let's see how we did. Oh, okay. I guess I really didn't need to push print. And we got 100% though, so perfect. Good job, guys. All right, let's actually move on to practicing some of these skills with different types of graphs. We'll start with bar graphs because they're probably the easiest, and we'll start with interpreting them. That means just reading bar graphs and then answering a question. Then we'll move into creating bar graphs, and then we'll talk about line plots, and then we can move on to stem and leaf. Okay, here we go. So starting off easy. It's taking a minute to load. There we go. All right, so this graph, bar graph, is showing chocolate consumption per capita. So across the x-axis, we have the different countries, and then we have two different years per country. So each country has two different years that they're going to show, 2002 or 2005. And then across the y-axis here, it shows how much they ate. So how much chocolate was consumed per capita in Australia in 2002? Go ahead and type it into the chat. How many kilograms, I guess, is the question. How many kilograms was consumed in Australia in 2002? So you have to read the graph. Go ahead, Sierra.
4 kilograms.
That's right. 4 kilograms. And I figured that out by looking at 2002, which is purple, Australia, and then I traced it over to 4. Easy. Okay, now it gets a little more complicated as we move on. Look at this table. So let's just take a look at the table. Population per square mile. So we have Montana, Wyoming, and South Dakota. And then we have the year 1990 and then the year 2000. So the population, it really only grew just...
I couldn't hear anything for a while.
Oh, I'm
My
sorry,
connection
Nicholas. Can you hear
lost.
us now?
Yeah.
Fantastic. Okay.
I just missed everything you said
Oh, well,
after you said something like I think after you said then we would create a bar graph.
oh, bummer. Well, I did record this, Nick, so you can go back and watch it later and kind of fill in your holes, but I bet it's just because you're not on an actual computer, so things are kind of messing up for you. Okay. So, looking at
Yeah.
the population per square mile, um, we have a 5 and it moves to 6, so it only increases by 1 in 10 years. So we got to look at which bar graph represents this data. Okay, so let's scroll down. And Nick, I'm going to actually mute you because I'm getting a little background noise, but go ahead and type anything you need to say into the chat, okay? Okay, so which bar graph shows that data? So we have to kind of keep going back and looking. Montana is 5 to 6, Wyoming is 4 to 5, and South Dakota goes from 9 to 10. Very good. It looks like, go ahead and type into the chat. Yep, the first one. Perfect. That's what everybody has said. So let's see. Good. Okay, look at this bar graph. So we have two different people in a spelling bee and their results. So one kid, Nigel, and then Millicent. Some interesting names. Number of words spelled correctly across the x-axis. So it looks like Millicent spelled 30 words correct. Nigel was much more fantastic with 100 words correct. So which table shows the same data? You could just put one or two, the first one or the second one. Good. Perfect. Easy. Let's just do another easy one and then we'll move on to actually creating bar graphs. Some friends compared how much money they have saved. So we have Alroy, Nada, and Derek. I don't know where they come up with these names, but whatever. Here's how much they have saved. Looks like Derek has saved, oh wow, that's the question. So how much money has Derek saved? Sierra?
$70.
That's right. If you look at Derek, he's right here. And if you just trace it straight down, he has saved $70. Okay, so that one was easy. Let's go to creating bar graphs, which is really not hard, but slightly more complicated. Okay, here we go. While looking through the almanac at the library, Eli noticed some data showing the population density of various states. Use the data in the table to complete the bar graph below. So here's our table. Pennsylvania in 1990 had 300, I'm guessing probably million people per square mile, or I mean 300 people per square mile. Okay, there we go. And it didn't change in 2000. New Hampshire did not change. Oh, wow. None of these changed. So go ahead and type into the chat what I need to fill in for Pennsylvania. What do I need to type in for 1990, which is pink? Good. So 300. And then what do I need to type in for 2000 for Pennsylvania? Same thing, right? Because it did not change. So let's go ahead and submit our answer. Easy. Okay. Getting a little bit more complicated now because now we have four different things to look at. We have data in the table and we have animals and their average lifespan, so the average amount of years that they live. So what do I need to type or draw for a kangaroo? How many years is the average lifespan of a kangaroo? 9. Good. Very nice. And then a mouse. What do I need to type in for a mouse? Looks like 4 years. So, yay! All right, let's submit it and see how we did. Awesome. Okay, let's do one more. They're getting a little harder each time. A sports reporter researched the average cost of professional baseball tickets in various cities. Use the data in the table to complete the bar graph below. So we have Kansas City, Boston, Tampa Bay, and Houston. So this is the average price of a ticket. So it looks like Boston's pretty expensive. How much is the cost of an average ticket in Tampa Bay? $15. Perfect. Okay. All right. So you guys are showing that you know how to read and create bar graphs. So we'll move on to line graphs. So let's move on. Okay. To practicing some line graphs. That's actually a different type of graph. Let's create them. Okay. Oh, this is, have you guys done this type of graph yet? The line plots? This isn't a line graph. Have you done this yet? Sierra, have you done it this year or some other year? I mean, not Sierra, Autumn.
I have done it last year,
Oh, you did it
but I
last
did it in one of the tests.
Oh, yeah, and it was on your interim test as well. That's right. Okay, so these are actually slightly more complicated, but not bad. So let's just do maybe one or two of them, and then we'll go on to some stem and leaf plots. Okay. Some authors wrote stories for a book of short stories. Use the data to complete the line plot below. So it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 authors wrote 0 stories. So what you're going to see is 10 X's, which represents the stories. Now we have 1, 2, 3, 4. It looks like there were 4 that wrote 1. So you'll see 4. So how many do I need to, how many X's do I need to fill in for 4 stories? Let's count the 4s. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. So 9 people wrote those, wrote 4 short stories. So then I would come and fill in 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Okay. Cool. All right, here we go. Students in Mrs. Romero's math class guessed a number between 1 and 5 and recorded the results. Use the data in the table to complete the line plot below. So here are the number of kids who guessed 1. 1 kid guessed 1. 2 kiddos guessed that the number was 4. 3 kids guessed that the answer was 3. 4 students thought that the number was 10. Just kidding, I read that wrong. I read it backwards, sorry. 1 kiddo guessed 1. 4 kiddos guessed that the number was 2. 3 kiddos guessed that the number was 3. 10 kiddos guessed that the number was 4. And 6 kids guessed that the number was 5. So, how many guessed 3? Well, you can just, actually, that one's probably the easiest one to read. 3 guessed that the number was 3. Okay, so you can just see 3 kids guessed that the number was 3. And there we go. Okay, so one more of this type. A pasta company asked people how much macaroni and cheese they ate. Use the data to complete the line plot below. So we have macaroni and cheese consumption, basically. So the times eaten looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 times that people did not eat the macaroni. So that was pretty easy. Okay. All right, you guys are doing great. Graphs are actually pretty easy. They're kind of fun too. This one makes you think maybe a little bit more. So here we go. Stem and leaf plots. What you need to know about stem and leaf plots is that the stem represents the tens position, okay? And that the leaf is going to represent the ones position. So I'm going to actually take a picture of this so that I can draw on it. Just a second. Okay, here we go. So if I'm looking at broken lights per string, it looks like there was one set of lights that had 40. There was one string of lights that had 41. There was one string of lights that had 52 broken, I guess, bulbs or whatever. One string of lights had 58 broken bulbs. This is quite a bit. I would think I would be taking these back. And then look, this is where you have to kind of count. 2 strings of lights had 60 broken bulbs. Do you see that? Here's the 6 representing the tens position, and then the leaf is the ones position. So just asking you this question, how many strings of lights had 62 broken bulbs? So go ahead and type into the chat, how many strings of lights had 62 broken bulbs or whatever? It's okay, Jacob. And you can see just by counting that there's 1, so there's 2. Looks like 2. All right, but the question asks us, how many strings had at least 70 broken lights? Well, how many times do you see the number 70 show up on this graph? Type that into the chat. Okay, so this is the tens position. So this represents your tens. Okay, so think of your place value chart. Oops, I'm going to go back to, hold on, sorry, I'm going to clear this board and take a new picture. Okay, so your stems represent your tens position. So like this very first value represents 40 because the leaves represent the ones position. So what's in the tens? Your 4. What's in the leaf or the ones position? A 0. And then we have another value. So we have a 10, or I'm sorry, a 4 again in the tens position. And then we have a 1 in the ones position. So that represents 41. So I'm looking at how many have 70 broken lights. Here's my 7. How many times do I see a 0? Just once. So how many strings of lights are there that represent 70 broken bulbs? There's only 1. I only see 70 appear once. Okay. 4. Oh, guys, I didn't read it correctly. I'm sorry. At least 70 broken lights. At least. So I have to look at all of these that are at least 70. So this one is 70, this one is 74, this one is 74, and then this one is 75. So there are at least 4. Sorry, I didn't read that correctly. Got to pay attention to what you're reading because that makes a difference. Okay. Okay, this one's easier because this one wants to know how many students scored exactly 28 points. So looking at my stem and leaf plot, here's the 20s. This represents all of the 20s. And this represents anything in the ones position. So there looks like there's 2 kids who scored 28 points. Good. All right, stem and leaf, here we go. Look at this. How many teams have, okay, here we go again, at least 64 members, but fewer than 85. So I'm going to take a picture of this one because this I'm going to draw on. Okay, so the question is asking us at least 64, but fewer than 85. So we've got 65, so that's 1. 72, so that's another. 73, that's another. 77, that's another person. 78, that's another person. 78 again, so that's another. 83, so that's another person. And then that's it because the next value would be 85. So 1, 2, 3, 4, 5, 6, 7. Looks like there are 7 teams that have at least 64 members, but fewer than 85 members. Do you guys agree? Autumn, what do you think? Thumbs up? Jacob, is this confusing for you, or are you starting to kind of catch on? Okay, so let's see, 7 teams. Perfect, we got it correct. All right, here we go. Let's do another one. This is probably the hardest out of all of the different skills with graphs, stem and leaf plots. What you need to remember, Jacob, is that the stems represent the tens position. Think of your place value chart where you have your ones, your tens, your hundreds, your thousands, and so forth. So your stems are your tens column, and your leaves are your ones column. So if I look at this, this represents 17. If I look at this value, that represents 23. If I look at this 2 and then this 3, that represents 23 again. If I look at the 2 and then the 6, that represents the number 26. Does that make sense, Jacob? Okay, good. What is the smallest number of roses? Everyone type into the chat. Okay, I got Sierra's, I got Jacob. Smallest number of roses, Autumn, and looks like Nicholas had to go. Smallest number of roses is 17. Good. All right. How many trains had at least, or I'm sorry, not at least, had exactly 68 passengers? So there's 1 train with 68. There's 2 trains with 68, and then there's 3 trains with 68. Perfect. You guys are catching on. Okay, how many restaurants were rated fewer than 50 points? So we got to look at not the 50 because we want fewer than 50 points. So let's just count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yay! You guys are doing great. What is the largest number of books on any shelf? The largest number would be, go ahead and type it into the chat. Perfect, Jacob. Awesome, Autumn. Great, Sierra. 80. That's right. Yay! Okay, give me a thumbs up if you're feeling pretty good with graphs, different types of graphs that we've worked with today. All right. Pretty easy stuff. Yay! Okay. Next week, we are going to be playing a little Jeopardy game on Monday, and it will involve I have a reading game and I have a math game. So it'll just be kind of like a fun review of all the stuff that you've been learning throughout the entire semester. We will not have any VCs on next Thursday, which is the 20th, because a lot of people are already leaving for Christmas break and will not be here for that particular day. So on Monday, we will kind of combine the two and play a couple games. But before we leave, are there any questions about today? Any questions about the different types of graphs, or maybe anything else that you're working on, like division or anything? Sierra, did I see your hand? I don't think your microphone's on, Sierra, if you're talking.
I'm not trying to talk.
Oh, you're not trying to talk? Okay, I thought your hand was up. Yes, Jacob, I know. I wish there were more boys in fifth grade too, but Nicholas had to leave. I think probably because he was like using his cell phone, driving around in a car in New York City, and it sometimes doesn't work as well as a regular computer. So anyway, guys, this was a lot of fun. Today was actually a little different. It was nice to see kind of a switch of topics and to work with graphing. So anything else before we say goodbye? No? Okay. Autumn, thank you so much too for your vote for the Apple Awards. I actually got the most nominations out of all the teachers in our school. But the teachers did not vote to send me. So, whatever. Yeah, go ahead, Sierra.
What are the Apple Awards?
The Apple
Yes.
Awards, you had to submit it by the 30th of November. It was your favorite teacher, basically. So, anyway, all right, guys, have a great day. Give me a wave. Goodbye. Bye.